So I'm going to do number 4 next. We have 3 log of 2 plus log of x equals log of 24. So all of my terms are logs. What I'm going to do is get the same log on both sides and then set them equal to each other. So that 3 at the beginning of this first log, I'm going to change that to an exponent here. So it'd be 2 cubed. And then I'm going to simplify it. So if I'm adding these 2 logs on the left side, that's like multiplying them. 2 cubed is 8. And I'm going to multiply 8 times x since I'm adding those 2 logs. Okay, if you're still having a hard time remembering your laws of logarithms, keep those notes out from last week that have them all listed, and that'll help. So, I have logs on both sides. They're equal. So I'm going to set this 8x equal to 24. Solve for x. So divide by 8. And x equals 3. For number 4. Okay, I'm going to go ahead and work number 5. I'm going to go through it kind of quick because you should have already attempted it. Okay, none of these terms have a log in it. So this is, let me see, type number 2 on your notes, where we're going to take the log of both sides and use our calculator to figure out an answer. But you have to get that 4 to the x power by itself. So we're going to divide by 5 to both sides. So 4 to the x power equals 13/5. Okay, now I can take the log of both sides. So log of 4 to the x power equals log of 13/5. I'm going to move that x in front of my log and divide by the log of 4. So you should get that x equals 0.689. Okay, if you didn't get that, I would definitely check your parentheses, make sure those are right. And number 6. Number 6, we have one term that is a non-log term, that -3. So this is the first type of equation on your notes that it talks about, where we simplify this and then change it to an exponential equation and solve it. And I wrote this wrong. There should be an x here. There we go. Okay, so on the right side, I'm going to go ahead and move that 3 to the exponent. So it's 4 cubed. Alright, so I have log base of 2 of x minus 3 equals log base of 2. And 4 cubed is, let me make sure I get this right, 64. Okay, now if you have a non-log term, you need to keep that log term by itself. Now I don't like my number to be negative, so what I did is I added 3 to the other side. So log base of 2 of x equals log base of 2 of 64 plus 3. And you want your logs to be on the same side, if you remember that from last week. That's where we kind of started this whole log thing. You need your logs on the same side, especially if you have a non-log term like this 3. So what I'm going to do is subtract this log base of 2 of 64 and move it to the other side. So it's kind of like whenever you're solving for x in an equation. You get your x's on the same side and you get your constants on the other. It's the exact same thing, except we're getting our logs on the same side and our constants on the other. Okay, but it's the same kind of principle here. So we have log base 2 of x minus log base 2 of 64 equals 3. Alright, so I need to simplify this left side. If I'm subtracting these two, my laws of logarithms tell me that means I'm going to divide those two. So x divided by 64 equals 3. Okay. Once it's simplified, as much as it can be simplified, I'm going to change it to exponential now. So start with my base and move counterclockwise. Okay. Now you're only going to change it to exponential if you have a non-log term. Okay. So don't try to make this too confusing. Just know that if you have a non-log term anywhere in that equation, eventually you're going to change it to exponential. Okay, that's the only way you can solve it. So this would be 2 to the 3rd power equals x over 64. Okay, now I'm going to solve for x. So 2 cubed is 8. I'm going to go ahead and change that. The opposite of dividing by 64 is multiplying by 64 to both sides. And 8 times 64 gives me 512. On your worksheet today, you're going to do evens only. If you have any questions, feel free to email me, rewatch the videos, look at your notes, all of that. And y'all have a good day.